Okay, so welcome everybody. I just took a look outside. I can't see any last minute people looking like they're just about to come in, so I think I'll make a start. Maybe one or two come in. So welcome to the session. What we're going to do this afternoon is talk a bit about research software development and the sort of funding calls that we run. The idea is that it's going to be interactive. So there'll be I'll give you the sort of agenda in a minute, but we'll have a couple of talks, and then I've got some questions that you can sort of get together and discuss. Because we didn't know exactly how many we were going to get. We didn't know whether we'd get 10, 20, 80 or whatever. So we have to be a little bit dynamic about how we do the sort of interactive session. But I think these numbers should work.
Just me.
Oh, that's okay. No, that's good. Thanks. Working. That's good. Right. So in terms of software development, so the development and maintenance of software is clearly key to the efficient use of compute resources. I mean, that's true at every level, laptop right up to HPC, but of course it's especially true for large complex HPC systems. And what we see all the time is changes in the underlying technology, and they of course require software updates. So updates to hardware, libraries, compilers, memory models, programming models, etc. They all require to go back to the code and make some changes, and sometimes quite significant changes. And the bigger the underlying change in those things that I mentioned and others as well, the more effort and expertise is needed, even just to keep simulations running, right? So not even necessarily to implement anything new, but just to keep the code running, you actually have to do a lot. You have to sort of, run faster, stand still, or whatever the expression is. And if you want to actually introduce new algorithms and new science, then you've got more work to do. So software development is at least as important as new hardware. I think we're probably more or less in agreement in all of that. So in terms of software development funding provision, so the actual funding itself might be provided in different ways and administered in different ways. So typically, of course, calls are administered via research councils. All of you have probably applied or been involved in some kind of application to a funding call that happens via a research council. But sometimes the calls are administered via a different organization. So today we're going to focus on two of those calls. We're going to focus on the ECSE. So in a minute, I'm going to talk about the ECSE, the Embedded Computational Science and Engineering calls that we've had that are run via the Archer 2 service. And then after that, my colleague Neil is going to talk about the Research Software Maintenance Fund that is run via SSI. And we'll also make a couple of mention of other schemes just to put things in context. When we come to when it comes to the questions that you're going to consider, you can sort of basically focus on those two calls, but don't feel that you are restricted to that, right? We're looking at the whole kind of community and the whole kind of landscape. So the aim of the session is for about the first half an hour or so, we'll give these talks on the ECSE and the Software Maintenance Fund. And then for the rest of the session, we're planning to use most of it for an interactive session. And that's where we'll probably break into maybe 3 or so groups and look through some questions. I'll put the questions up. You're not restricted to what's up there, but they're the sorts of things that we'd quite like you to look at. And then the aim is to collect feedback on the points raised. So we're not just going to, sort of get you to say stuff and we think, oh, that's interesting. We will actually be taking notes, writing down, and these are things that we can actually take back if and when we have more calls of this kind of nature. And then the final aim is, depending a bit on how much time we have, is that oh, yeah, sorry, I meant to say also we'll want to get a list of priorities based on the discussion. So we'll get your feedback on the various different points, but we'd like to just be really clear on what's the priorities here. And when we've got all those things, we can have if there's time at the end, and we can have a think about how they fit into the sort of calls that we've been running now and what the implications might be based on a current knowledge of the sort of landscape and the way things have run up until now. So it's important to note that the actual funding itself does come from the research councils. We don't have it, we don't provide it. It comes through us, but it comes from the research council. So we don't have a say on exactly what to fund and when to fund it. That comes at the UKRI level. but we do have some say in how calls are run, and we do have a voice here where we can sort of say, well, at sessions like this, people have got together and these are the priorities. So these sessions are quite useful, I think, to gather that. So although we don't make the ultimate decisions, we do have some say. Okay, so I'll start talking now. Unless anybody's got any burning questions, I'll move on to talk about the ECSE calls. So I run these calls via the Archer 2 service and within EPCC. So what is the ECSE program? So it's basically a software development program that funds RSEs. I'll come on in a minute to what the constraints are in terms of what RSEs and how much and what do we actually fund. But basically, it's a software development funding program. So recent calls were administered via EPCC via the Archer 2 contract. So Archer 2 is the UK National Supercomputing Service, and the calls have run through that program. So the idea here really was that when a program like Archer or service like Archer 2 is funded, instead of giving all of the funding to the service providers, to actually embed some of that funding within the community. So EPCC, who are running Archer 2, we get money to run the service, and we have some computational science and engineering support, but then a much bigger pot goes out to the community. We administer that via open calls, and that's what I'm going to talk about here. So across Archer and Archer 2, the two recent services we've had, the funding has been provided across around 40 institutions, and actually even more than that when you start to include COIs and PIs who've been involved in various projects. And if you actually look at that map there, that's an intention to sort of show the diversity of around the UK of where these calls have been funded. The size of the spot there sort of shows you roughly how many, although obviously it depends a bit on how you bin these things. But it just shows you that we have had funding all around the UK. And as I say, that's just the RSEs who are funded. If you include COIs and PIs, you get more there. So it's quite a lot there. So I thought it was worth just a little bit about the sort of evolution of the program over the various years. So when Neil comes to speak, he's going to talk a little bit more generally about the sort of history of software development calls that we've had within the UK. So here's specifically how it's worked for the ECSE program. So it actually started off as the DCSE, the distributed CSE, under the Hector program back in 2007. And so there were a number of DSE projects then, and then when we moved on to Archer, it became the ECSE, the embedded CSE program. So as you can see that we're going on for 20 years worth of running now, which actually I hadn't really realised until I thought about the slides. This whole idea of this concept has been around for now nearly 20 years. So at the moment we're coming towards the end of the Archer 2 service, and we still have some projects that are running from some ECSE projects that are running that run till the end of the service. And then towards about a couple of years ago, we also had these GPU ECSE calls, which I'll explain a bit more about in a minute. It was specifically to fund codes working with GPUs, and they run up until March 2027. So still, although we don't have any open calls at the moment, projects are still very much ongoing. And then at the end, it's a sort of blue box with some question marks. Next National Supercomputing Service. We don't know yet what's going to happen there and how ECSE type funding will be included. So question mark there, but so this is where maybe we have some influence. Okay, so the remit has changed a bit over the various calls. So under Archer and Archer 2, EPSRC codes were always eligible, and for some calls, NERC were also eligible. And then later on, when we had the GPU calls, and these were aimed at basically running on UK's digital research infrastructure and future exascale services, national AI services and Tier 2 HPC services, basically anywhere with large-scale GPU systems. And then the remit changed to being for all of UKRI. So it wasn't restricted to EPSRC or EPSRC and NERC. And we got a sort of consequent explosion in the number of proposals, but we'll see that in a minute. So what does it fund? So ECSE funding, it's not all about just making your code go faster. We do get a lot of projects that are about improving the performance, improving the scaling, but it's not all about that. It may be implementing algorithmic improvements, maybe making your code more portable, it may be making it more scalable in terms of CPU or core or node counts. It may be also about enhancing the sustainability or the maintainability of a code or the usability. Might be putting in new science, might be more about porting to a new system, so say porting to Archer or porting to GPUs. It may be about adding functionality to existing codes, or it may be taking from a smaller system, a tier 2 type system, up to Archer 2 or GPU. Or it may be looking at new workflows. And we've had projects of just about all of those. Well, I think all of those, and probably even one or two more things. So if you want to take a look at the kinds of projects that we have run, then the best place to look is the Archer 2 webpage. You can see all the reports that we've had in so far, and they're still coming in because projects are still ending. And we've also got a Zenodo area as well, where the final reports are all kept. So do take a look at that, because there's an absolutely huge range of projects to look at, and you can see exactly what we've been doing. I should also add that if you go to the Archer 2 reports, that front page there, each of these, you can't really see it in the small text here, but each of them has a little publishable summary. So it's a sort of more user-friendly summary of what the project is about. And then you can click through to the final report, which is much more technical and explains, exactly what they've been doing with the coding and the algorithms and so on. So who does it fund? So the funding is provided for RSEs located at the institution of the PI, or it might be an RSE from the Archer 2 centralized support team, or it could be an RSE from a third-party institution, or it could be some combination of the above. So you might have, for example, a local RSE who really knows the code, but maybe isn't an expert on HPC, and then you might take somebody from the Archer 2 service who's an expert on HPC, but probably doesn't know the code or the science. So those two work together. That would be a typical combination, or it may be just one person. The funding for ECSE is not covered the PI or COI role. Okay, it purely funds the RSE. We do allow the RSE to take on the PI or COI role if they've got enough support within the project, or if they've got enough experience. So it's actually been a very good opportunity for some younger or early career researchers to take on that role and be the PI of a project. But we don't actually fund that role. So you can, if you like, self-manage as an RSE if you've got the skills and the support, but we don't actually fund that role. We expect that the PI and the RSEs are to be UK based. We basically follow the UKRI's rules on PI eligibility. And when the panel assess a proposal, they look at the whole team's ability to deliver the project, including the PI, the COI, and the staff skills and the support that can be given to RSEs if they're perhaps earlier on in their career. And we do have quite a lot of RSEs who've worked on ECSE projects who are just out of a PhD, for example, and they've gained a lot of skills from that. Okay, so within Archer, that was the previous service, and the current Archer 2 service, we run 26 calls. We had typically 3 calls per year throughout most of the Archer and Archer 2 service. Obviously, that changes a little bit, at the beginning and the end, but it's in steady state. It's kind of 3 calls per year. Overall, we've awarded 2,105 person months. I think if I've divided that by 12, right, I think that's 175 person years of effort. That's quite substantial, actually. And that's been across 193 projects. Quite a big program. Well, 2 programs, Archer and Archer 2. So just looking at the size of an individual project, so the number of technical staff in an individual project is typically between 1 and 3. So you have quite a lot of projects where there's just one RSE working on it, and then you might have a few where, as I say, you might have 2 people, might have somebody from the local team and somebody from the CSE team, and then occasionally we may have some where there's 3 people. I think in the early days we may have had 1 or 2 projects that had 4, but typically 1 to 3, and the average is about 1.2. So you can say it's biased quite a lot towards the 1. And in terms for Archer 2, the size of the project, each project was between 3 and 18 person months. That varied a little bit depending on where we were at the programme, because obviously if you're near the end of the programme, you can't really fund 12 months and there's not 12 months left. But it's basically between 3 and 18 person months. And the average there is 10 person months. So that's probably quite important to take note of that, because that gives you an idea of the size of these projects, right? Typically between 1 and 3 people, typically 10, average of 10 person months. The duration could be longer. So it was very common for an ECSE project to be awarded for more calendar months than person months. So somebody might work on this, for example, for 50% or 70% or something like that. And that's been really useful for people who may have other responsibilities that they can't completely give up, or maybe part-time, like that. Then towards the end of the sort of Arch2 period, so 2 years ago, we ran two funding calls for specifically GPU ECSE projects. These were much less connected with Archer 2. They basically were for running, as I mentioned earlier, they were running on, for codes that were going to be running on GPU hardware. And this did not have to be associated with Archer 2. Archer 2 has a small testbed GPU system, but these codes ultimately could be running anywhere on large GPU systems. So we ran two calls in 2004. First call received 51 proposals. Second call received 69 proposals. And when I added up how much money was requested, that was £24 million. Okay. As I said, there were 51 and then 69 proposals. If I try and, it's a bit difficult to know for sure, but if I try and take away the duplicate, so the people that applied the second time as a resubmission of the first time, I think there were 91 unique proposals. I haven't quite worked out what that does to the money figure there. I guess it's about 3/4 of that. But as you can see, a lot of proposals, and there were very many good, excellent proposals that we had to reject. In the end, we could only fund 12 projects. We had £4 million. We were hoping that we were then going to get another sort of ingest of £3 million for the next year to be able to fund a few more. And then unfortunately that didn't happen. So we could fund just 12. So you can see that ratio there. £24 million requested, and we could only fund £4 million worth of it. So there's clearly a big demand. As I said, we had to reject a lot of good and even some excellent proposals. And I know I won't say too much because I know Neil's had the same thing with this software development software maintenance fund, where how do you deal with rejecting a proposal which is essentially excellent? I mean, what do you tell people? So when you can't fund that. And at the moment, there's no funding for any further calls, but we are hoping to say that the next national supercomputing service will have something associated with it. Okay, so just looking at time, I'll try and zip through this. Basically, the process here is not so dissimilar from most funding calls, I guess. The call opens, publicised. Candidates submit online. They do this via the SAFE. So the SAFE is the thing that runs all the sort of basically everything within Archer 2. It's the sort of web interface to Archer 2 and some of our other services. So candidates submit via that, then closes. Then submissions are assessed. They're assessed technically and scientifically. We then have an independent panel which meets to decide funding. It's important that panel is independent. That is independent of EPCC, because we also bid into it. So we set the panel up, and we choose a chair, but then they go ahead and they decide what gets funded. And we don't always get our proposals funded, so it's generally independent of us. Then awards are made. Successful and unsuccessful candidates are informed of decisions, and everyone receives feedback. Always quite a difficult time, as I said, because we don't always fund every project, but this is the way calls are. One just thing I wanted to mention as well, just as a bit of a highlight really, is that we did an early career panel observers call where people could apply to come along to a panel meeting and observe what happens. These have been very successful. So over all the calls we've had 50 observers, around 50 observers attend panel meetings. Usually about 3 or 4 per panel meeting. They're all subject to the same basically the same guidelines as the panel members. So the same sort of confidentiality, same GDPR, same conflict of interest rules. So for example, if somebody has a proposal in, or somebody they're working with has a proposal in, then they wouldn't come to that panel meeting and so on. And then they would go out of the room if something from their institution was discussed or something. But anyway, that's been a good opportunity, which has been very successful, and we would like to carry on with that. So yeah, we don't yet know how future funding calls will be administered. We're hoping that there'll be something ECSE-like in the future, but we do have some influence over the aspects of the programming, working together with UKRI. We do have some say on the frequency of call, the timelines, some say on the process in terms of setting up the panel and making decisions. We have some say in terms of the makeup of the panel. We usually put together the guidelines for the applicants, guidelines for panel. These, UKRI do look at these and check they're happy with these, but we do have some say in how all these are put together. And we also have some say in how the money is distributed, so how big the awards are. So the sort of things that you might say today, they can be factored back into this. Okay, so that was all I wanted to say for ECSE. So just moving on to some other calls, just to put things in context. And then Neil's going to talk about some more. But so DURAC have an RSE scheme so DURAC is basically the body which provides resources for all the theoretical cosmology, nuclear physics, astrophysics, particle physics, solar and planetary science. And within that, there's a group of RSEs. It's possible to apply for RSE effort within the yearly calls that we have, what's called the RAC calls. And the effort then comes from existing RSEs to work on codes within DURAC. So we had five projects funded back in April, around 39 person months, plus there are ongoing projects from previous years. So that gives you some idea of the scale. And then just about something else. So the UK AI antenna at EPCC. So my colleague Lorna here is involved in this. So that aims to boost the AI adoption among businesses and researchers. So it's working collaboratively with the team out in Stuttgart, HLRS. It's a wide range of targeted users, so startups, SMEs, larger industry, public sector, focus on a region by region approach. There'll be direct engagement activities involved in it, roadshows, workshops, etc. But there will be a regular call for applications to work on codes. The effort there will be provided by RSEs who are already at EPCC. So a little bit like what I just described for DURAC. Okay, so I'm sorry, not interactive session yet. So I'm just going to move over, and my colleague Neil is going to talk about the Research Software Maintenance Fund. So I'll stop sharing. I suggest that we maybe continue for now, but we'll take questions at the end of our talks, if that's okay, just if everybody's happy with that, if has anything burning.
Thank you, Chris. So my name is Neil Chu-Hong. I'm Director of the Software Sustainability Institute. And what I'm going to do is go through a little bit about some of the context around funding for research software, and then talk a little bit about the Research Software Maintenance Fund. So some of you will be aware of some of this history, some of you will not. I think one thing that is clear is that there have been different shifts in the way that research software has been funded as we've gone through the development of computational research. So originally, what we had was mostly research software being a byproduct investment, either in research or in computational hardware. So there was a lot of stuff that was developed on research grants. And the maintenance of it was pretty much just everyone knew it needed to be maintained, but there was no real funding for it. The one difference, particularly in the UK, was the collaborative computational projects, which are one of the longest running ways of directly funding flagship software codes in computational research. In the 2000s, there was driven both by the rise in data, a difference in the way that government strategy was set out, and I think broadly an international feeling that there needed to be more investment in computation and data science. We saw lots of investment through things like the eScience program, the cyber infrastructure programs, and so on, that were looking at the middleware. So it was the generic things that supported particular methods that might be reusable at that level. So there was more engagement with industry. There were more opportunities for exploitation. A lot more of the software started looking at how they could follow the same principles as some of the open source work that was being done at the time. And then we had the RSE movement from about 2012 onwards, which really was focusing on understanding how we built up the capability of institutions, universities, research organizations, industry to maintain the code themselves. So there were lots of different calls that started to come out there. There were things like the RSE fellowships from EPSRC and Software for the Future funding call, which was one of the first of these general software development calls. The BBSRC had their Tools and Resources Development Fund, and we saw a lot more increase in philanthropy in this area. So charitable foundations, people like the Sloan Foundation and so on, who are supporting specific problem areas. So as an example, one of the largest funders for software over the last few years has been the Wellcome Foundation, but that has been primarily focused at the life and medical sciences. And now we're in an age where we are seeing another shift with generative AI on one side and digital sovereignty on the other side. And that is changing up the way that we see software being developed and maintained again. So this is a diagram which hopefully makes a little bit of sense. I apologize. Some of this was done on a train, so my choice of colors is particularly poor. But it's trying to again give a sense of the fact that there are lots of different stages in the life cycle of research software. So you get the sort of stuff which is scripts right up at the top side, which is really about something that you're writing for yourself. And then it goes through stages of maturity where it goes from being something that's just for you to something which is relied on by hundreds and thousands of people. And what I think is clear is that you need different sorts of funding for the different sorts of stages. And some of that funding is kind of coming as a byproduct of just doing the research itself, things like the standard responsive mode grants, impact acceleration accounts and so on, student projects, and some is about intentional development of the software. Some of that is through the things that we've been talking about, we'll be talking about, so things like the Research Software Maintenance Fund, the collaborative computational projects, the ECSE calls, but there are some interesting new things that are happening. So I think one of the things that you're starting to see is there are pilots like the Better Methods, Better Research call from MRC, where people get to nominate software that is fundamental to the types of methods and techniques that are underpinning their research. You're seeing things like the Open Source for Science Fund run by Renaissance Philanthropy, which is pooling together money from multiple charitable and national funders and going through a single review process to support the maintenance of different open source software. And one that's just set up is something called the Open Source Endowment, which is, again, a pooling fund, but here it is about getting individual donations in to then go out to open source projects. So we are seeing a shake-up in the way that things are being done. But the rest of this talk, I'm really going to be talking about how we're doing it in a more traditional sense with the Research Software Maintenance Fund. So what is the Research Software Maintenance Fund? It is a approximately £5 million fund that's run by the SSI on behalf of UKRI. And it sort of has an interesting dual purpose. It's both there to give money to software that is used by the community, supports UK research, and is in need of maintenance. But it's also there to try and understand how we might fund research software maintenance in a more effective way. So the way we're doing this is in a very open way where we are talking about the details that go under the covers. And some of the things I'm going to mention here really are going into the details of what it takes to run one of these calls and hopefully give you some perspective, either if you're an applicant or if you are someone who's involved in reviewing or funding, about what are the sorts of decision points that might need to be made. So it's set up as 2 rounds. We have already gone through the first round, and there were a number of awards made there, and those projects have started. And we're at the stage now where the full applications for the second round are all in, and the panels will be held in early July. So again, like Chris, unfortunately, at this point, we don't have any additional money to give out through this, but we will see where that goes in the future. One of the things that we were keen to do with the RSMF was to try and support development that was for the kinds of codes that were used not just in the UK, but used internationally. And so what that meant was that teams could apply that included co-applicants from other countries, from industry, from charities, from individual contractors. It could support research in any discipline. And that has implications as well. So the biggest implication is that there was a very high level of interest. It is not quite the most oversubscribed software call. That accolade goes to round 5 of CZI's Essential Open Source for Science, which got around about 600 applications. But it was still much more than we expected. And there are a number of reasons behind this. The first one is that it was the first call that was more generally open, and we got a wide range of people from who were not applying into the other sorts of calls. The other thing was that it also launched just at the point where the US dramatically cut all of the funding that it was providing to software. So we got a lot of applications that had joint US consortia as well. And so you can kind of see this sort of level. You have 360 expressions of interest, inviting 150 applications, 143 submitted, and we get to fund 4 large projects and 9 small projects. Round 2, 229 expressions of interest, 61 applications, 60 submitted. We expect to fund about 10. There is this concept of a SLASO point. It's the point at which the total value of the time spent by the applicants, the reviewers, and the administrators exceeds the total value of the funding call. And this is the thing that I really care about. So can we make it more efficient? Because we can kind of look at this, and one of the big problems is you kind of go across the scoring, and you go, so in our first round of the expressions of interest, we looked across this. This was a program team review. There were only 7 of the 360 expressions of interest that could be considered partially out of scope, and only 1 that was fully out of scope. And even that was a great project. It just wasn't in scope. When we got through the expert peer review panels, there were only 11 of the 143 full applications that fell below the threshold of the 4 on the UKRI scale, which is should be funded. And there were none that were below the 3 threshold, which is could be funded. So basically, we could have given funding to any of those 143, and definitely could fund about 132 of them if we had the money. Same thing's happening at round 2. Of the 229 expressions of interest, there's only 18 that fell below that threshold of 4. So we have an issue of just there being a lot of really good pieces of software with really good projects out there. And so you can do the analysis. You can kind of look through, so a lot of these are estimates, but if you kind of take the sort of Fermi approximation approach, you start getting some quite disturbing figures. You're going to run round 1. We probably asked of the community if they weren't reusing any of their work, if they hadn't done any of this themselves, about £1 million worth of effort from the community. So that's a challenge. And really, the only way that you can reduce this is by reducing the number of full applications. But that gives us a problem. So the biggest issue we have in efficiently giving out funding for any sorts of funding calls is to do it more efficiently, you are asking applicants to accept a loss of control about how they can influence the decision. So it becomes less about how good your application is, but it becomes more about how lucky you are. But maybe everything's about luck anyway. So a little bit more about the calls themselves. We took a look at how this was going between different research areas, because partially we also wanted to see if we could improve from round 1 to round 2. In round 1, one of the things we noticed is that we had less applications than we expected from the social sciences and the arts and humanities. One of the things we did for round 2 was run some specific sessions just for the arts and humanities and social sciences to help them understand what was required of them from the call. Did more targeted advertising, and we were slightly successful, particularly in the arts and humanities, in increasing the number of applications going in. There is still a strong preference from things coming from the physical sciences and computer sciences, though. One thing that's not in the slide, though, is that actually the life sciences are probably the most successful for Research Software Maintenance Fund. And our hypothesis is this is because there's been consistent funding opportunities for the life sciences through the BBSRC and MRC, which probably means that applicants are better prepared to understand how to write these kinds of applications. We looked at different sorts of activity that people wanted to request. Unsurprisingly, almost everyone wanted technical support and to do technical activities, but there was also a strong amount of interest in community activities and governance activities amongst the larger projects, and that's to be expected. I think it's something that we were putting in the criteria and we think is really important as pieces of software get more established. The one where I feel we could still do better, but I'll explain a little bit about why we think there are still barriers, is around the job role of the lead. So one of the things we were aiming to do with this was to have more research software engineers being the leads of these applications. And I think one of the big challenges is that it's stayed stubbornly about the same. And looking into it more closely, one of the biggest problems we have is that in many institutions that are applying, the research software engineer is not allowed to be the lead. There are a number of institutions which appear to have a policy that says there must be an academic as the lead of any quotes research grant. So that's something that I think we need to address. We're working on with funders, but it's one of these big problems that even if the rule from the funding call says one thing, the rule from the university might say something else. And indeed, one of the large grants that we have is in this situation where, so actually, this is slightly not as it is, because I've included them in there because they have a token academic who's only there to satisfy the institutional policy. And there is a letter in the application that says they will play no part in the project and they will take no money from the project. So if you looked at it properly, it would probably there's one that flips there, and it looks even worse. So that is, I think, a real problem for the area, and it's going against what we're seeing in some other funding calls around, for instance, research facilities, where there is a clear sign that for research facilities, if you have a research facility manager leading the call, you have a higher success rate. So I would have loved for this to have shown that there was a higher success rate of an RSE-led call. Actually, there's not much difference when you look at the figures, and there's a lot we can do there. So anyway, some kind of key takeaways. The biggest challenge for funders is that the volume of applications is such that you need to kind of think of different ways of doing things. The way that many funders in other countries are doing it are through more focused schemes. So rather than having an open call for everything, you go, this is only going to support things that are to do with statistical packages. This is only going to support things that are to do with mathematical libraries. And then you cycle through them. The problem with that is that means that if you are unlucky, it might be 7 or 8 years before it rotates around to your type of software again. There definitely is a real benefit in providing more tailored support, examples and guidance to groups that might not be in a position to submit high quality applications. But a lot of this needs to be done with the institutions, because I think that's the biggest blocker. And yeah, it's very difficult to provide meaningful individual feedback, as Chris said, if the feedback is your application, you were just unlucky. Because if you scored a 5.9 out of 6, but 50 others scored a 5.9 out of 6, what can I tell you? You really are just unlucky. But there is a lot of discussion in the meta science community and across funders. There is something that's now convened by the Research Software Alliance called the Research Software Funders Forum, where all of the people who are involved in funding software are talking about all of this. And so I think what we are seeing now is the funders being willing to share their experience and to look at ways that we can improve this and improve the efficiency. Takeaway for applicants, particularly if you ever are able to bid into something like the Research Software Maintenance Fund or the Open Source for Science Fund, is it's helpful if you understand what you need funding for. So rather than trying to just go into a cold code, have a plan as part of your software development roadmap for what you need funding for. And that makes it much easier to basically reuse this on multiple applications. If you're able to demonstrate the impact on of your software and research, that is probably the key differentiator. The ones that did rank lower in the Research Software Maintenance Fund, the key thing that they failed to be able to convince the reviewers of was what was the impact on research. It was great software, there was impact, but could you show that it really was helping produce either world-leading research or research that really underpinned a lot of society? And it really helps to know the landscape that your software operates in. So who uses your software, what's it used with, what are your competitors, because that gives you a much more convincing argument for why you need the funding at that point in time. And that's the key thing, is you're really wanting to show why your software needs the funding now rather than in 7 years' time when the next cycle comes around. So I think I'll leave you with the unfortunate thing of going, funding is still just so much driven by luck, but I hope you are all lucky. I'll hand back to Chris.
Yeah. So if you just, yeah,